Good morning again, and welcome back. How many of you have not seen the first part of this session? Okay, so there are a few of you. Then let me reintroduce myself. My name is Tiberiu COVACI. I'm originally from Romania, and I told your colleagues that has been here at the first session, like 10 years without 2 months ago, I was doing my very first public presentation in room C. Of a mistake, it wasn't by choice, but then, you know, it opened my taste for doing public presentations, and I've been doing it ever since. I'm based in Sweden. I've moved around the world a lot. That's why on my name you would see /E, because up to 3 months ago I used to live in Spain, in Tenerife. So I just moved from Tenerife to Sweden. So a very good choice of places, I would say. But I was... since I moved back, I worked as a head of Cloud Academy for a company called Cloudion in Denmark, in Copenhagen, and we are doing cloud transformations for the big actors in Denmark. I'm a Microsoft Regional Director, which is a misnomer. I'm not working for Microsoft, I'm not directing anything, and I don't have any region, actually. Living on the tiny island of Tenerife, we were 2 Microsoft Regional Directors there. So that was a little bit, you know, like a way too high concentration of, you know, regional directors in one single place. This is actually an award. Microsoft considers us trusted advisors. That's the name they are using, actually. If you look on the RD site, we are trusted advisors, and Microsoft asks us questions, and we come with feedback from our customers or from what we are actually finding during our work with Microsoft technologies or with other technologies. So they are doing that. The most valuable professional title might be more known to others. That means that I'm doing a lot of conference speakings, user group speakings, maybe blog posts, which I'm not doing anymore, but all kind of community engagement. And as a way to say thank you for all the time that I put and get nothing, you know, I don't get paid, Microsoft invites us once a year to go to Redmond and get to talk with the product team and see exactly what they have in pipe. We have regular meetings with them online. So it is an interesting thing because that gives you a lot of information about what Microsoft is doing and where Microsoft is heading, which is why I started this presentation in the first place. So you see there is a lot of code magazine stuff on that. And the reason for this is because this presentation is it's something that I work together with the guys from Code Magazine, so they do the same kind of things, mostly in the US, they do this kind of presentations. Originally, this is thought to be a workshop, either a half-day only presentation and some code demos, or a full day with participants working on that. I'm doing this as 2 sessions, so I cut back all the demos, mainly because there are a lot of errors that can happen, you know, and I want to be successful. I just don't want to fail. I'm kidding. It's just, I don't think there is enough time to do all those things. So, we talked about a lot of things. We talked about where Microsoft is. We talked about .NET, and we talked about the web development part. Now we came to the development environments and languages. So if we look at those things, when we talk about the languages, we have C#. This is the biggest language of all of them. This is the leader of the pack. This is what Microsoft is investing heavily in. That doesn't mean that they're not investing as heavy in VB.NET. The only difference now is that all the demos, all the code examples that you would find online are primarily written in C#. Why? Because if you can read C#, you know VB.NET, or you can read VB.NET without any problem, and the other way around. The only thing you would have to do as a VB.NET developer is to ignore the semicolons, and maybe to put, instead of curly braces, to put begin or end, depending on the direction of your curly brace. So, you know, that's how you learn VB.NET. So now you're a VB.NET developer in case you're just doing C# before. But joke aside, VB is still going strong. There are a lot of projects using VB. I do have a lot of customers coming and say, we want to transform everything in C#. Like, it doesn't make any sense. All the libraries you already wrote and you can use, keep them in VB.NET. If you create new libraries, you can create them in C#. Everything being .NET, the communication should be, you know, the interaction between them should be no problem. So that's the best way to go. And then we have F#. F# is for functional programming. It is, it is a smaller community. It is the kind of, old boy clubs, like, it's impossible to get in, and, like everybody that's outside, hey, that's a stupid thing. As soon as you go inside, those are the stupid guys. So it's something almost like this. But it is mostly done for functional programming. And again, being a .NET kind of thing, or being everything compiled for the .NET framework, you can run it on top of the CLR. But it helps a lot with the functional way of thinking. So when you have applications that are highly functional and they require this kind of thinking and implementation, F# would be the best tool for the job. So if you have to do a lot of calculations, if you have to do a lot of immutability and work with the data in a safe way, I think F# it is a good solution for that. And of course, all three of them have a big role to play. I think we are not, we are far from that time when, like, I don't know if you remember, about 10, 15 years ago, the number of languages supporting .NET was about 27. Like you had COBOL.NET, you had Pascal, you had a lot of other things, like Java, it was J# actually called. All of them were, targeting .NET as a framework to be able to run. I think what Microsoft tries to do now is to just make it a little bit smaller and concentrated. But I think they have enough for what they need. This is when we are targeting the .NET framework. Then we have JavaScript. There was some JavaScript for .NET as well, but again, I wouldn't recommend you go there. It was very ugly. For two reasons. It was JavaScript and it was .NET for JavaScript, so JavaScript for .NET. So it was, two things there. But JavaScript, it is a very interesting language. It has prototypical inheritance, that's what it's called. And of course, we are all object-oriented programmers, so a lot of us are trying to just make it work, with the way we are thinking about how programming language works, which creates a lot of issues. And a lot of people do not really understand. And heck, for me, it took about 2 years until I could say, yes, actually, I know some JavaScript now, although I was working with it all the time. It is, in spite of the books you read, if you don't face the problem yourself, you don't really understand some of the things that are happening, and you really need to go to dig deeper. So that's why Microsoft created something called the TypeScript, which is just a superset of JavaScript. And it came about 5 years ago already, so it has some years, behind it. It is strong. It got a lot of support from Microsoft. It is open source, and they use TypeScript to write TypeScript. So it is, like dog-feeding themselves in order to create this language. What Microsoft used to say is like, okay, if you take a JS file and you put a TS to it, it will just run. But be ready to be offended, because it will give you some error and it will show you some of the stuff that you should not do in JavaScript normally. So it still does some compilation and some best practices. What Microsoft did with TypeScript, they took Douglas Crockford's book, which says JavaScript, the good parts, and all the things they added, they are making sure that they are following those, like 97 pages in the book, and the code generated is actually clean, or cleanish JavaScript code. But anyway, it follows the best practices of how you should write JavaScript in the first place. Both JavaScript and TypeScript can be used for front-end and as well for back-end together with Node.js. So if you want to do back-end development, you can use TypeScript and Node.js and run that. Again, I would recommend going into something more, more stable, like .NET Framework. But for the UI, it's the language of the choice at the moment, unless Blazor, gets the adoption that it needs. And then we have Python and R. Python and R are languages used mainly for data scientists. So if you want to get into data science, R might not be the language of choice. It's for statisticians. It's a very ugly language. I never looked at it. Python, it's a C-like language, and it helps you, and it makes it much easier for you to get into this area. Now, let's look at the tools. What we have now, it's Visual Studio 2017. And what Microsoft does over and over again, it improves the performance. It has a lot of editor improvements. I used to call Visual Studio back in the days a glorified notepad. So it was a notepad with a lot of plugins that will help you do a lot of the work. Now I think this title now is taken over by Visual Studio Code, which I will show you in a minute. There are a lot of versions and a lot of improvements. As I told you in the previous session, my very first version of Visual Product was 1.5 back in 1994. So I have 24 years working with that. And one of the things that I have to say, I feel at home. Every time I open Visual Studio, it's the same old look and feel. It's the same, the same integrated development environment that I can just use. I can do my code editing, I can do my compilation, I can do my debugging, I can do everything within one single tool. Deployment, of course, although you don't do right-click deployment, But if you want to do it, you can do it without any issues. Now, another improvement was the way you do the installation. So you have a selective install. You download a 700K file, and then you choose from that what do you want to download. So you can go up to 30 gig of downloads, or you can just choose the stuff you need for your own environment. There is a new site called visualstudio.com, and the latest release, it's 15.9.2, or at least it was yesterday. So 15.9 came last week. 9.1 came 2 days later, 9.2 came 2 days later. So I'm not sure if today it's the right number, but I will tell you what it was yesterday, okay? So let's see what's new in them. In Visual Studio 15.8, they added support for multi-card editing. So it is improved. So now if you choose a word and you want to change it in 10 places, they will do it a little bit better. If you do Git branch switching, so if you want to move between branches, normally the way they used to do that, they would download the whole solution and then they load it again, and so it will take a lot of time. Now they make it much quicker, and they have improved the unit testing execution. So it works much quicker for you to run your unit test. You don't have to wait for them a long time. And they added support for TypeScript 3.0. Now, if we look at 15.9, they added improved debugging experience for Nugget packages. You can do, if you use C++, you can do step-back debugging, so you can go back and see, you can either debug forward or backward and see exactly how the things were evolving. There are new TypeScript features that they added support for it as well in Visual Studio. If you want to do Node.js development, that's improved as well inside Visual Studio. And they have support for Xcode 10 if you do Xamarin. And if we look at the versions of Visual Studio, the one you can use freely today, there are some limitations. It's not the full Visual Studio. But the things that you are missing are the things that are related to architects and to testing. So if you want to do development, you can just use Visual Studio Community, which is free, as long as you are not doing any production development as part of an enterprise. But as an independent developer, you can use that for free today. Now, there are some paid versions, like Visual Studio Professional and Visual Studio Enterprise. Those are coming with a MSDN subscription, which gives you access to Azure resources as well. So with Professional, you get $100 per month for consumption in Azure, and for the Enterprise, you get $150 to consume in Azure every month. So you have those money, and at the end of the month, they will reset the clock, so you would start again with a new 150 and new 150, so you have that to work with. I mentioned earlier Visual Studio Code. Visual Studio Code and Visual Studio is exactly like Java and JavaScript. So they have nothing in common except that they are coming from Microsoft, and they have the same root in the name. But Visual Studio Code came to life as a way for us to develop or to actually edit files inside Azure. So Microsoft were thinking, how can we help the developer after deployed something on Azure to do something and edit some of the files? So initially it was called Visual Studio Online. The only way you could use it, it was inside Azure. But then they liked what they got, and they said, maybe we should create a tool out of it. So they put Electron around it, and then they create it as a tool that you can run on Linux, you can run on Windows, you can run on a Mac without any problems and without any difference. Guess the language is written in? TypeScript, of course, or JavaScript if you transpile it, yes. It's free. It has an open, it is an open plugin model, meaning that it's very easy to write plugins for it, and you can use it without any issues. And it has one thing. When I started to look at Java, for instance, I was using Eclipse. And the thing I hated the most about Eclipse was the fact that when it comes out of the box, it's empty. Like you just have a text editor, but nothing else. And then you needed to know which plugins you need to install in order to start working on your project. And you need to recompile your Eclipse in order to just be able to start working with Eclipse, which was a little bit counterintuitive. Visual Studio Code, at the beginning, I thought it does exactly the same stupid thing. It turns out it's not. It's using AI to actually understand what are you trying to do. And it comes with suggestions. It's like, oh, it looks to me like you're writing C#. What about OmniSharp extension? Do you want it? Oh, it looks to me like you're running PowerShell. Do you want the PowerShell extension? Oh, that looks like a Docker file. Do you want the tools for Docker to run with? So they offer those suggestions and actually makes it very straightforward. It's not, I mean, like, yes, yes, yes. If you press yes, you get the tool that you need with a lot of things. And it's actually very fast. It works very nice. Up to last year, it wasn't possible. Now it's possible to do the debugging inside Visual Studio Code. And I love the fact that I can do, in one tool, I can do backend and front-end debugging. So I can take my web page, I can use Chrome tools for Visual Studio Code, and debug actually inside my Visual Studio Code as I would do in an F12 session in Chrome, which again, it's a very cool and very neat feature that if you look at it. So talking about all those things, I think it's worth talking about Xamarin as well. So if we look at Xamarin, it's very important for building native applications on iOS or on Android. It's C#, it's .NET, and it started from the Mono team. I don't know how many of you are familiar with the history. I told you earlier that Microsoft promised us a framework to rule them all, to be available on all platforms, but they stopped at Win32. So then was Rotor, that was available for Apple, and then there was Mono, that was created as a platform independent, that was actually running both on Linux and on Windows and on Apple back then. Microsoft just ignored them, and those guys had to put with an uphill battle for a very long time because Microsoft will change the specification. They wouldn't give them the information. So when they introduced, for instance, TPL, the task parallel library, Microsoft didn't give them too much information to run with. So they had a little bit of an issue there. Then finally, Microsoft decided it's a good time for us to buy it. Not because they like the guys, because they need them. They realize we actually, if we really are serious about all the open source, if we really are serious about doing, like every device, every platform as we are talking about, we really need something in this space. And we have a lot of .NET developers, and we really needed Xamarin. So that's why they did it. So if you want to see, there is a YouTube video. Again, I will share this presentation with you after the session, so you can just go to the link without any problem. So of course, if you want to write Xamarin applications and if you want to run everywhere, Microsoft took the Xamarin Studio and they called it Visual Studio for the Mac. Don't be fooled; it's not the full Visual Studio. If you really want to do development in the full Visual Studio, you would need a Windows machine still. And I don't think they will go the way, creating a full Visual Studio for the Mac because it requires the full .NET framework, which you don't have. So that's why they're not doing it. But if you want to do iOS applications, if you want to do .NET Core applications, you can just do it with the Visual Studio for Mac. This is, I would say, the pièce de la résistance, what Microsoft announced at Build, and I really like that, is the Visual Studio Live Share. How many of you have seen this? Ooh, very few. So, what's the promise here? It gives us the possibility to share debugging, or actually to share programming sessions. I can open Visual Studio on my machine and create a live share with someone. I will send him an invitation, and he can open that either in Visual Studio or in Visual Studio Code. It is the same. And what he gets to see what I show on my screen, code-wise. So I'm sharing the code. I'm not sharing my screen, meaning that if I choose a certain color scheme for my environment, that's what is it going to be used on my machine as well. So I get to see, so he gets to see his colors, like you see here on the left, we have some colors there, on the right we have different colors. Those are two different sessions, and everyone can keep actually and run with his own colors without getting the interference. So I'm not sharing the screen. I'm sharing the coding session. So it's very good for, you know, if you want to do pair programming, sorry, if you want to do pair programming, is very good. If you want to do debugging, is very good because it has advanced debugging support as well. So I can start a debugging session from my machine, although the application runs on a different machine. So I won't need any of the libraries installed there. I don't need anything in there. I can just run it. It looks like it runs on my machine, but it runs on the other machine, and I get the updates. I get the information about the stack. I get the information about the variables, about all the things directly on my machine. So it is very, very powerful. Just have a look at it, and I will guarantee you would love it, especially if you need help from someone and you always end up, when you share screens, you know, you end up in a remote desktop or in a team or Skype session. This one will save the day every single time, seriously. So just have a look at it. So that being said, we are done with the development tools and we are done with the languages. Now that's the important part, or the interesting part, containers. So, containers were invented to solve a simple problem. Who knows which problem? Works on my machine. That's the problem, okay? I think this is to show the extent we as developers are ready to go to invent things or to abstract things in order to avoid to talk with our IT ops or with our IT admins, okay? So if something works on my machine, I don't have to come and talk with you. I just give you my machine. Now take it and run it in production. Of course, now as a developer, it puts a little bit of onus on me because I need to make sure that it runs on my machine before I give it to the IT ops, but at least they stop bugging me, you know? So I think that's the problem. Joking aside, I think that became, at the end of the day, the unit of deployment. So that's how we deploy application nowadays. What they create isolated environments, like virtualization. But there is a small difference. You don't get a new copy of the operating systems every time you run that. You just have the base operating system, and then you add on top of that. And the way that works is actually quite simple. In Linux, there is something called process virtualization. So when you virtualize a process, in Linux, you would say, okay, you are the only one running on that machine. No one around is here. So if you want to talk with them, you would need to actually talk as you would talk with a different machine. So that was the base idea. So what they did, they said, okay, let's use that. Let's create images where we actually start the process and we add the stuff that we need on top of that. And then, you know, we create running containers so we can run with that. So that's how it was done. And the company behind it, it's called Docker. So Docker is actually the ones that invented or created the containers. Now, if you look at the Docker, it has support for both Windows and Linux. So now there is Docker for Windows 2.0, and Microsoft works very, very hard. If you look at Windows Server 2019 Nano, for instance, it is what Microsoft wants to get. They want to have full support for containers. Now, if you're really serious about containers, I wouldn't look at Windows just yet. And the reason for that is the size of the images. So when you end up having an image that's 7 gig big, I think it's a little bit too much, if you ask me, you know? But that's how it works. So I wanted to do something. I wanted to deploy an IaaS. And it's very simple. You just start with a Microsoft. Either you can start with a Microsoft Windows Server base image, or you can start with one that already contains IaaS. And then I wanted to deploy my application inside that IaaS and then create an image, and you just take the image and then you can run it on any machine without any problem. Now, my application was about, I would say, 2 meg or 3 meg, so it was a small application. As soon as I created a container, the image generated was about 2 gig, which it doesn't really equate. It doesn't really make sense for me, you know, that big of a difference. So Microsoft is really working on that. If I would do the same thing with Linux, first, I wouldn't be able to run IaaS, so I think that's not a solution. But if I do that with .NET Core, the images are much smaller, so the sizes are much, you know, are much easier to maintain, and it's much later, much easier for us to move them around. when you have a 7 gig image, and if you want to download it here to make a demo on Docker for Windows, I think it would be quite impossible, you know, like the speed with so many people around would not be the one that you would want to have a successful demo. So Docker became the de facto standard when it comes to unit of deployment. Now, the problem with that is, you know, people talking about microservices, and micro, I might not be sure that's the, you know, the right term, because the microservice can be as big as you want it, but it's about the fact that you can isolate different parts of your application, and you need to make them work together. And in order to do that, you need something called orchestrators. So if you have a database, if you have a UI, and if you have a backend for your application, and you want to run it, you know, in a container way, you need to make sure that you know how to find your database, you know how to find your, you know, your backend, and so on. And that's why you start using orchestrators. Now, we have 3 of them that are available at the moment. The first one is Swarm. It comes from Docker, and it's very limited in functionality. And if you talk with anyone, they will tell you if you're really serious about doing production work with Docker, I would recommend you are not looking at Swarm, because it's limited. It has a desired state, meaning that if I say I want 4 instances of that particular image, it will create them, but if I kill one, it will create one. If I change the number while I kill one, it will be a little bit, you know, confused, and it won't actually do the right thing. So it is not really there, and I don't think it will ever get there. But for, you know, for easy applications, for testing, and for understanding how it works, it's quite easy to use. And what it does at the end of the day, you can have several machines called engines, and then you can put them together, and you have master nodes and you have slave nodes. And the slave nodes are the one running the workloads, and the master nodes are the one making sure that they send the loads to different masters. Then it's the DCOS. DCOS can run, amongst other things, containers. So it can be an orchestrator. It's not only an orchestrator, it's a little bit more. It comes from, it's based on the Apache Mesos, and it is created by Mesosphere Inc. And Microsoft, for instance, added support to that in Azure. So if you use Azure, then you can use this without any problem. Then we have Kubernetes. So Kubernetes was originally created by Google, but Google saw that it's actually very popular. And contrary to their way of doing things, instead of keeping it for them, they decided to open it. And I think it was a wise decision. If they would have kept Kubernetes for them or for themselves, people would have looked the other way. Now, what Google needs, they need adoption, at least for their GCP, for the Google Cloud Platform. They really need adoption. And the only way you can need adoption is to make it as easy as possible for people to move around. So when you look at Kubernetes, you can deploy different kind of containers, but the most pervasive one, the most prevalent one is actually Docker. So you can use Docker and deploy it there. In Azure, there is something called Azure Kubernetes Services. So what you do there, you actually deploy containers, and you say, I want to use the Kubernetes engine in order to be able to manage those and to orchestrate and have communication between different containers and so on. Amazon has its own called Elastic Container Services for Kubernetes, so they call it EKS. Microsoft is calling it AKS, and there is the Google Kubernetes engine. So the theory now would be that you can create your application, and actually the practice too. If you target containers, you can start creating your application, and you go from your on-prem, where you run on your physical machines, you run your Docker container inside Kubernetes, and you can move it to Amazon if you want, or you can move it to Azure, or you can run it in both sides. So that's not a problem. Of course, there is a problem of communication, or actually, like latency between the nodes, but that's a different story. But in theory, you can run your applications multi-cloud, multi-platform without any problem, just because you managed to put it in a container. So yes, starting from working on my machine, and avoiding to communicate, I think we managed to create a different value and make it much easier. And again, a lot of big enterprises are really embracing containers, mainly because it makes them independent of a cloud provider. So they have very little things that are specific to a cloud provider, so they can just make their application work. Okay? So those are the containers. Now let's see, cloud and Azure. What's cloud? Someone else's computer, isn't it? That's how we started, at least. So when we look, the first ones that came were Amazon. Of course, today is Black Friday. We need to thank them for that. Because of the Black Friday, they had to have a lot of machines just to make sure that they are looking and they are, they get the right, sizing. So they don't want to lose any sales because they didn't have enough capacity. But then they realized that the rest of the year, not really. I mean, then there's Christmas, then it's Mother's Day, the Father's Day, and then it's the, Independence, and again. So there are a lot of other things, but in between, their machines were almost idling. So they decided to do something about it. So the first thing they did, they said, okay, we can sell some of the storage we have. So that's how they started. They started with S3. And people said, yeah, but only storage, maybe that's not enough. We want some more. So that's when they start giving them all those compute instances. So then we got, Azure Compute, we got the virtual machines. That's what it is at the end of the day. And it actually started to take off. That was in 2006. In 2008, Microsoft realized that we might need to do something as well. So Azure, it's their answer to that. Now, there is a small difference. When Microsoft started with Azure, they started with PaaS offering, meaning that what they said, you know what, we don't believe in giving you virtual machines. That can do any data center provider at the end of the day. Any hosting provider can do that for you. What we want to do, we want to give you services. We want to give you services that will help you in your distributed computing problem. So when you have those kind of issues, how would you solve them? So that's what we got in there. They added those services specifically for us to get started. Now, as developers and as IT pros, we were always in love with our machines. So one of the things that, we asked from Microsoft, and we've been very upset with Microsoft, was the fact that they don't give me access to the virtual machine. So they started small. First, they added RDP support for the, for the web worker and for the web role and worker role. Then they said, okay, if you really want the virtual machine, I can give you a virtual machine and you can do whatever you want with it. And then they realized, you know what, if we really go this way, I think we've done some wrong decisions at the beginning, so let's start from scratch. So then they came about 4 or 5 years ago, they came with a second version of Azure, with the Azure resource management model of deploying things. Now, you can build applications in any tool, any language, any framework. They have support from everything from the smallest databases to SAP. If you want to run big things on that, you can run SAP on Azure. So they do a lot of things. When they first started, I've seen their very first version of Azure back in 2009, when an Azure data center in a box. They had it at PDC, which now it's called Build. So it was in Los Angeles in a big Congress hall. They had a big container full of machines, and that was the idea. You get a container, you put it in a data center, you connect water for cooling, you connect power and network, and that's it. You don't need anything else. Once more than 50% of the machines were gone, they will take that container and put another one in place. After a couple of years, they realized that might not be the best way of doing it, so they went back and now they do the classic data center things. Now, why would you go with Azure when you can go with any data provider you want, or you can buy your own data center? Well, the first thing is the economy of scale. You can buy so many machines, or Microsoft buys so many machines that you get them very cheap. You can't get them at the same level. Plus that they have a lot of other things like security, and they have, like elasticity. So there are a lot of things there that will help you to do your job as a developer. So if we look at Azure Data Center, it looks like this. This is a campus. Microsoft usually, when they choose a place, they choose it to have enough room around it, so they can extend and they can add more and more, because it's always an increasing demand. There are more and more people wanting to move to cloud. So I have some examples here at how data centers look like in different places of the world, like this in Dublin, in Amsterdam. So like if you look at the fields on the far right there, Microsoft is actually already bought those and they are building data centers, so they are increasing. The ones here in the back, they're already there, so they're already working on that to build. Or actually, this is about 2 years old, or 1.5 years old, so I'm certain there are already data centers in place over there. Usually those are kept secret for one single reason, security. You don't want someone come bombing and stuff. So there is an agreement. Even the satellite pictures won't show that. Most of them won't show the data center. So they know about them, so they keep them used because it has to be, you know, somewhat safe. When you look at the pictures, you have regions. So it says 50. Actually, last week were 54. I haven't looked today, so I don't know if there are 56 or there are still 54. It is an ever-growing number. Started with 4 regions for a very long time. Now we are up at 54. Still 140 countries. So there is availability. It's a very wide availability. Now, talking about Azure, there is one thing a lot of people do not know. Azure, it's the second largest dark fiber provider in the world. How many of you knew that? Dark fiber, it's the high-speed, fiber connection between data centers. So, if you look at, like all those ocean things that, like ocean cables they are dragging, they are using dark fiber for that. All Microsoft data centers use their own networking infrastructure, Microsoft networking infrastructure, meaning that if I want to communicate between two data centers, it is guaranteed to be private. So it doesn't go through public internet, not even, a VPN, it is a kind of a private connection that you get, but it still goes through public network, while Microsoft uses their own. So there is a big investment. They really believe in that. If you look at what Microsoft, they talk only Azure, 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 Azure everywhere, and I think they do that for a simple reason, because it is indeed important for them. They have a lot of certifications. Whatever application you have to use, if you have certain regulations in your area, look, I will guarantee Microsoft already has that, so it would be easier for you to start developing there. And it's used by 90% of the Fortune 500 companies. Of course, that doesn't say anything, because if you ask, Amazon, they will give you exactly the same number. If you ask Google, they'll give you exactly the same number. Just because someone from a company on a Fortune 500 created this, a service at some point, makes them customers there. So it's not, it's still a lot. There are still a lot of, a lot of workloads, and it's actually getting a lot of uptake. So what we see now, it's a second wave. More and more companies are actually very serious about moving to the cloud. Couple of years back, they weren't very sure. A lot of people just got scared about their own job. Like, how would I do if someone comes and then, remove my cables, or I can't plug the cables anymore. I need to give that to someone else. So instead of working strategically, I have to do stuff locally here. So again, I think now the wait-and-see period is done. A lot of people just realize this is the way to go, and they are convinced about that. How many of you are familiar with what happened about 2 months ago when Azure was down? No? Very few people. Okay. So what happened was that there was a hurricane in San Antonio, which killed all the power in the region. And because of that, Microsoft's own data center had to start the generators. So they started generators to actually give the power to that. The generator starts to hit, and the guys that were actually working in the data center, they missed this information. The reason they miss it is because they got so many warnings that one that was important, they actually missed. Because if they would have seen that, they could have started taking down some of the services manually and not allowing the generators to heat up. But all the generators heat up, and then they said, okay, panic mode, everything needs to be shut down. We don't want to have a fire, so we'd rather shut down everything. Now, it took Microsoft 20 hours to get back online during a hurricane, with those problems. A lot of people are like, yeah, what's so interesting about that? How many of you, how many companies do you think would be able to do that today in those conditions? If you get a disaster, how many do you think would be able to restore full capacity with very little loss of data in less than 20 hours? Of course, there are a lot of people, they have RPOs and RTOs, and they can tell you a lot about that, and they have, half an hour we need to be back online. Most of them won't be able to do that. So this is actually just to show how much it matters, the things that they are doing. And then, like being that big, how much it helps as well, you as a customer at the end of the day. Because if you can get back your workload within 20 hours, that's actually a very good result. There are a lot that they have, disaster recovery strategies, but they never try them out. They just have the backups, and that's it. They don't try it out and see the backup is working or that they can recover. And we've been heard stories about that very, countless times so far. But anyway, talking about Azure, there is one problem. Like, if you have a nuclear plant and you want to use Azure services, would you want it on the internet? Regardless of what Microsoft guarantees security-wise. No, you won't. Or if you want to have access to Azure services while you are on a cruise. Again, the satellite connection is so expensive and so prohibitive that it doesn't make any sense. You would rather actually have someone moving the bytes inside your ship than actually communicating like that. So the solution to that is to use Azure Stack. Azure Stack, with pieces of hardware, you buy a rack with a cluster installed with everything that you need to run Azure services. So of course, based on how many of those racks you are buying and how many machines you have, how much storage you have, you can run some of them. But most of those things that makes Azure great, with the platform as a service solution, you can run them now by yourself in your own data center. So there are customers that prefer to have their own version, and that's how they do it. They put in their own data center, they put an Azure Stack, and they run it there. And of course, we have something else called the cloud and the edge. So Microsoft said there are a lot of services that you can use inside Azure, but then you want to use them as well on your prem, and you don't really want to have a connection all the time. So you want to be eventually connected. So that's why they created the edge notion. So you can use that, you can get some of the services, and you can connect whenever you get a connection, or you can even do stuff like when they showed that at Build. You can take a model, you can train it, with machine learning, and then you can do some image analysis. And the model actually, it's about 120 meg big, and you can put it on a Raspberry Pi. And talking on containers, they do a lot of work on containers now, so you can get Docker containers with all those models already created for you, so you just start using them. You don't really have to think about installing, third-party software and stuff like that just to be able to use artificial intelligence or machine learning inside your applications. So it is very good for disconnected scenarios if you start using that. So talking about that, we have something called the serverless computing, which is a misnomer. Not the first one, and not the last one, I'm sure. Because it's not without the servers. What it means you as a developer do not, or you should not care about the server. You say, you know what, this is the piece of code I have. Call it Lambda, call it Azure Functions, call it whatever you want, and please run it for me under those circumstances. Either that I get a webhook that will trigger it, or that, I have a timer, or I have something. But whenever that happens, please run this piece of code for me. Because what I'm interested in is not, did I put the server with the right version of .NET Framework, with that? No, I'm just interested in that piece of code. And of course, for Microsoft makes sense because they get paid for running your stuff. For you makes sense because actually when you're running that, the price is very low. So I have a friend in Australia, and he's running a site called Have I Been Pwned? And he gets about 2 billion hits a month. And he was showing, he had a blog post last month about how much did he pay for using Azure Functions for 2 billion requests. And it was $75. So there is a big win here for a lot of people. I recommend look for Troy Hunt and look for his blog post from last month when he shows exactly how much he had to pay for using the serverless things. So if we look at Azure services, one that would be interesting to mention in this scenario would be actually Cosmos DB. Why is it important? I think Cosmos DB gives us a lot of a lot of the power when it comes to data storage. What it is at the end of the day, it's an infinite pool of database. So it's a big database that is automatically distributed. So you don't have to think about distributing that database. You don't have to think about how exactly is done the distribution. Of course, if you care about consistency, then you need to factor in that, but it has support for that. If you don't care about consistency, you care about eventual consistency, or you care about the data being replicated, that's a very good service. And the nice part is that it gives you, so this is a database pool or a pool for the data, and then on top of it, you just put different APIs. So you can use Cassandra, you can use document model, you can use a lot of other like SQL or Azure tables. Whatever type of API you want to use, you use it and you get access to the data that's behind that Azure Cosmos DB. So it is very powerful, and I really recommend you have a look at it. And of course, if you've seen Richard's session yesterday, there is no, we can't actually avoid looking at AI. I don't know, artificial intelligence as opposed to natural stupidity, or what? It is, it is that. But what does it mean at the end of the day? We have stuff like, yeah, natural stupidity. I say it once more because some people didn't really get it. Okay, I'm laughing by myself. Good. We have machine learning, and machine learning became possible, although it was around for a very long time, became possible because of those big elastic pools of servers that were made available by the cloud providers, including Azure. So what that meant at the end of the day, it meant that I don't have to invest a lot of money or a lot of time, because that was always the question. Okay, I have a model, I know I need to run it, I need to run a lot of things in order for me to get a good answer. But what do I do? Do I run it for a year on my machine, or do I buy enough machines so I can run it for a day? So that was always the trade-off, and I don't know exactly how I can do that. So now with Azure, with the cloud, I can just say, give me that big machine. I want to run this for 1 day. I will pay for 1 day of running the models and everything, but then I get the results what I wanted, and I have not invested in the hardware. I have not lost a lot of time, and I still got the answer I wanted. At the same, at the end of the day would be, I would have to pay for that, but at least I know I get the things that I need. So if you look at artificial intelligence, it is made possible by the machine learning. So Microsoft called it at the beginning predictive analytics, because that was the whole idea. We can make predictions based on the patterns we see on your data. So we can take that, we use machine learning, we get the streams of the data, and then we calculate that, and then we can tell you, based on the historical facts we have so far, this is what we predict would happen. So that's what, at the end, would be. Now, we have the artificial intelligence, or actually the assistants like Cortana, Alexa, and Siri, and so on, and so on, and so on, that will give you, a smart access to things. So I was actually impressed to see that Microsoft has a site where you can use Cortana for that, and you can actually put a CC when you want to set up a meeting with someone. You just get a discussion, you CC Cortana in there, and then Cortana will take over and say, oh, so I'm Cortana, I'm Henrik's assistant, and I've seen that you want to set up a meeting. Looking in Henrik's calendar, those are the days he can do that. Can you take any of them? I'm like, yes, please take Thursday morning. And then she said, okay, so you Thursday at that, and with a calendar invite and everything. So he just starts that, and then I'm the one being able to respond to her and say, yeah, please use that, and then does the whole thing. So I don't have to go back and forth and, do a lot of questions. So it does help us in many, many ways, and I think, it is very good. Now, when we look at artificial intelligence, there are a lot of achievements. Besides beating, Chinese at Go, we do have some interesting stuff like speech recognition. Back in 2017, they can recognize the voice, like human parity. Meaning that if I talk with someone from Australia, both me and the computer will be as confused. So we won't understand. That's, I know, Richard, you're there, but we will be as confused. So that's what it means by human parity, So if I don't understand, they won't understand. they can, so machine reading comprehension, again, so they can understand the text. So it's not, oh, they can read the text and they can do the grammar. They can understand the meaning of the text, and you can actually ask questions like you would ask, you know, in a test. Did you understand? I give you this text. Can you understand what it meant? So at that level. And of course, we have human parity in translation. So back in March, they could have someone speaking in Chinese and then being automatically translated in English while they were speaking, so you could get that kind of parity, which was, again, a very good thing. So, of course, how do we get there? We have for machine learning, we have the ML.NET. I really recommend you look into that. I think there is a session later today about ML.NET, because Microsoft wants us to have a look at that. There is actually ML.NET 0.7, I just found out yesterday, so they do increase that. And you can use machine learning already, or you can do the trained models and stuff, and then you can use .NET frameworks like a language you are familiar with in order to be able to get access to that. Okay? So with that being said, I would say we live in a very, very interesting world. Microsoft especially is doing a lot of things to help us as developers. If you have any questions about all the things I've talked about, I know there are like 1,000 technologies that I mentioned. Come and see me, I'll be at Ask the Expert. Thank you.